Hello everyone, this is the BNB Chain Club, and today we're going to start on a series for a complete walkthrough on how to build a real-world crowd sale on BNB Smart Chain that can be used to raise funds in a real-world ICO. I'll show you how to build a prototype ERC20, BEP20 token, and crowd sale with smart contracts that can be deployed to the BNB Smart Chain in order to raise funds in an ICO. I am going to walk you through each step in the process of developing these smart contracts and deploying them to the live network. This series is designed for beginners who do not have experience with Solidity and are not familiar with how ERC20 token work. Today, you'll be compiling a simple Solidity script and learning about the Remix development environment. This video will give you the opportunity to use and understand the following: CodePaint for writing code, the compiler to compile the code, deployment to deploy the code onto a BNB Smart Chain, and the blockchain inspector to see the blockchain process the code. Now, there is a prerequisite that you need to do. If you have not installed and connect your MetaMask wallet to the BNB Smart Chain testnet with test token, you may pause the video and follow the guide in the link at the description below. Once you have done so, you should have your MetaMask wallet being connected to BSC token to BSC testnet with some testnet token in your wallet address. And without further ado, let's get started on your first lab. Remix is a Solidity open source IDE used to write, compile, and deploy Solidity code. Solidity is a programming language used to write smart contracts. To access the online Remix environment, go to the URL remix.ethereum.org. On the left side, this is called the side panel, where you are able to select on this icon to go to the icon panel. On the right side, this is called the main panel, where you're able to write your Solidity code on. And below, this is called the terminal panel, where you're able to see the transaction of executing your code. Let's create an empty workspace by clicking onto this. What we want to do first is to rename your workspace. By default, you will be able to see two test files which we will not be going into today. But let's first create a folder called remix.contracts. And within this folder, create a new remix file named basic.so. What we are going to do here is to have a sample code that allows us to save and retrieve a value onto the blockchain. You can find the code reference in the GitHub page link below in the description. So let's go ahead, copy and paste the code into this file. The first line here is telling us to have a compiler version that is of the specified version in this line, or a version newer than this. Pragma is generally the first line of code within any Solidity file. Pragma is a directive that specifies the compiler version to be used for the current Solidity file. The symbol arrow here specifies that the source code is for a Solidity version greater than 0.5.0. So let's go to our compiler panel to make sure that our compiler is of a version that is of 0.5.0 or more than that version. Once you have selected the correct compiler version, you should get a tick here which indicates that it has been compiled successfully. Next, we go to the Deploy and Run Transaction panel to try to deploy this smart contract. In order to deploy the smart contract to BNB Smart Chain, we need to change our Remix IDE environment to the injected provider MetaMask, where you have already set up to be connected to the testnet. After doing it, you should be able to see your MetaMask account address listed like so, which means you are connected to the BNB Smart Chain testnet. Value equals 0 here means no BNB money is being transferred out for the upcoming transaction that you are about to execute. Now, make sure you select the contract you want to deploy, basic.so, and hit the deploy button to deploy your smart contract to the BNB Smart Chain testnet. Check the deployment has worked. The tick icon indicates that the contract has been deployed without any errors. Fun fact, deploying means that the code has been compiled from human-friendly words to computer readable data ready to be executed by the Ethereum virtual machine. The code data is then saved onto the blockchain as a new transaction. Now, let's click on this down arrow here in the terminal panel to see more details of your transaction. The variable status indicates the success or failure of the transaction attempted. As our transaction hash, anything that happens on the blockchain is called a transaction and is given a unique identifier based on its hash value. Every transaction must happen from some account, and this is for the from field. The to field indicates the destination account. Gas is the total cost of deploying the contract. Transaction cost is the total cost of the transaction in the contract. Input is the input to the transaction in hexadecimal. Decoded input is basically your input to the transaction in text. Likewise, the opposite for decoded output, which is the output of the transaction in text. Logs contains all extra information. And lastly, value is how much Ether is transferred from one account to another account in Wei. So another way to verify that your contract has been deployed onto Binance Smart Chain is to copy this transaction hash and go to BSC scan to view this transaction. Remember to first change your BSC scan network to testnet. And then query for the transaction hash that you copied. And as you can see, this is the valid transaction and indeed the one that you executed earlier. Take note of the field called to here, which tells you the address of the contract that you deployed. Okay, so now that your contract has been deployed onto Binance Smart Chain, let's try to execute a smart contract function where, according to the code that we have written here, we can store and retrieve some data onto blockchain using this contract that you have deployed. Remember the address that I've mentioned to take note at BSC scan? It is of the same address as indicated here, which is your contract address. So I want you to open up the contract interface for simple storage, and you see two functions, set and get functions, as coded in this field here. So just a quick explanation of the code here. Basically, as self-explanatory from the contract name simple storage, we are basically just creating a variable called stored data to store the value. The set functions helps to set a value to that variable, and your get functions helps you to get the value that is stored in the variable. So let's go ahead and set a value for the variable by entering a number into the set text box and click on the set button. 10. Observe the decoded input in the terminal panel when I open up this transaction. Here, you can see the value that you have put in at the set text box, 10. Now, click on the get button and observe the decoded output in the terminal panel. Here, you will see the value that was set in the variable earlier. Remember how I said that the value equals 0 here means that no BNB money is being transferred out for the upcoming transaction that you are about to execute. But if we look at it now, after we deploy and execute some code, there seems to be some difference in Ether value in the account we use to deploy the smart contract. And this is because per transaction, you will need to incur a gas fee that is to be deducted from your wallet. So all the transactions that we have been making so far, a gas fee will actually be incurred, and that will actually be deducted from your account wallet. If you happen to make some changes to the code or you want to create a new contract, what you need to do is to redeploy the smart contract the same way you did earlier, and you can see all the versions of the contracts in the deployed contract section here. So let's redeploy the contract again. And once you have done so, you can see all the smart contracts that you have actually deployed in this section here. This is the old one and this is the new one. The latest deployed contract will be added into this section here. To delete all the deployed contract from the list, you can click on this bin icon here. And to delete a specific contract, click on the X button here. Just to take note, I recommend to clear the deployed contracts before deploying the new contracts to stop confusion in cases where you're not sure which contract to interact with. Also, deleting a contract here does not mean you're removing the contract from the blockchain. You are simply just cleaning up the remix interface for yourself. The nature of blockchain is immutable, therefore no contract can be removed or deleted after deployment to the live network. And with that, we have come to an end to this video. I hope this introductory video has helped you to get started and familiar with Remix environment. If you have any questions or input, do comment at the comment section down below and remember to like and subscribe. Have a nice day.